So guys, hello and welcome back to the next lesson in volume in motion. So in the previous lesson we just created our first simple volume fabric simulation with a simple pop wind. That's it. But now we want to get involved the velocities from the smoke to get like a better simulation and get a more organic, a better behavior of the fabric. And we will do that now. So I will dive up here, so to the normal sub level. Let's lay that out here quickly. Okay. So we will start with a simple sphere, because of course we will need like emission for our smoke. I will pump the uniformal scale a little bit down, just give it some frequency. And for the fabric, what I want to quickly do is to just move it up a little bit. So just like that, maybe. That should be fine. So 0.5 up. Cool. Back to our sphere. What we will need is like here. We will need velocities onto our sphere or onto our geometry, and we will do that with a WAP. So press tab, type in WAP, get the simple attribute WAP, and I will call that create v for velocity, or just call it vel. So we can then pipe this velocity into our smoke simulation. We did that in the first chapter, but now we don't mesh it. We will use the outcoming velocities to then drive the volume simulation. Okay, I will dive in here and we will just make a simple setup for now. For example, the coal noise. The coal noise will give us a vector. We can pipe that out, for example, directly to velocity, and have a look. Dive up one level, go on the node info and press V. And now we already can see we've got some beautiful velocities here. Of course, what I will do, I will get an anti-alias noise and just try to combine several noises. Let's get a fit here, and currently the anti-alias noise is a 1D noise, but I want a vector noise, so free floats. Pipe it into the fit, and I want to fit it as usual, minus 0.5 to 0.5, and let's just have a look here. I will just get in a direction, so of course you can always go to the minus value, but I want to give it a little bit of a direction, so I will not go too harsh into the negative values here. And then what we can do, we can multiply the whole thing, or let's just add it to the curl noise, and we'll get something like that. The multiply here, we can use that. So multiply in here, and for example a constant, a vector constant, free floats vector. And now you can of course play, for example, with the direction a little bit. So upper direction. What you can do, you can normalize it if you want that, but I don't want it because I want a different length or magnitude on my vectors. So you can normalize them, or you can normalize them and then randomize them again with maybe a float value and multiply each single vector with a value. But I will just leave it like that for now. Of course we can later do that. So we now got our velocities. Now we need a pyro source. the pyro source. Cool. Pipe that in here. And I will just call that create smoke. And what I want to do, I want to just initialize a basic smoke here. So with density and temperature. And then one more attribute will be our velocity. So we then can pipe the velocity into our smoke simulation. So we got three attributes now: density, temperature, and velocity. Particle separation, I will go to 0.05, and it should be fine, I think. Yeah, okay. Let's just leave it. And then, of course, a volume rasterize attributes. And what we want to rasterize is the density, the temperature, and the velocity. So we got like three fields: density, temperature, velocity. Let me just get the voxel size down here a little bit. And that's basically it. So this is just like a basic setup for our source. Let's place a null down and call it in_source. Of course, you can call it whatever you want. And then we can start to to basically set up our simulation. So let's get another DOP network. Pipe that into the first import, and I will call it just sim smoke or simvel for our velocities, and dive inside. So we will need a smoke solver, just a simple smoke solver here, and pipe that into the output. Then required objects, of course we will need a smoke object. Press tab and type smoke object. This will be that, and then you can connect this. I will rename that to smoke_out, so we can later with an import field node we can later then pick just one field, for example the velocities, and get only them out to then affect our volume simulation. After that, what I want to do, let's get a gas reside fluid dynamic. Gas reside fluid dynamic, pipe that into the second input, and on max bounds we will just disable the clamp to maximum. And can we do something else? No, I don't think so for now. Okay, and then of course we need to source our smoke simulation. As usual, the volume source, like in the first chapter, volume source, and then just click on something else and then source smoke, and you will get these kind of three sourcing fields: density, temperature, vector. Cool. So now we can just start our simulation. Oh, there's one error, I think. Oh yeah, we need to specify the input, so the input will be the first convex geometry, of course. And now you can see we'll get a simulation that will rise up. One thing I will do, I will just disable the buoyancy lift here. And another thing, a little bit higher resolution maybe. So for now it's like 0.2, so we can go like for 0.05. Looks much better here. Cool. What we can do now, we can go on the smoke object, disable density, and for example enable the velocities. And now you can already see like basically a line representation of our velocities here. So that's pretty cool, and we will need them, of course. So dive up one level. So, and for the initial import from our velocities, we will need a node called import fields. So dot import field, and I will rename that to import vel, for example. And now, of course, when we play the timeline, you will see nothing, because the DOP import fields will require a DOP network, so we'll just drag and drop that in here. And we will also need a field to import. So press plus, and we want to import the smoke underscore out. So smoke underscore out. And which field? The vel field. So just type in vel. And now we will play our simulation, and you can see that we will successfully import our velocity field. And for a quick visualization, what you can do, you can place down a scatter, for example. So a scatter node here, scatter, and you will scatter into the smoke, and a volume trail. You will require the velocity volume, that's that, and the points, of course. And now you can see representation from your volume, from the velocities. Cool, so that's that. What I want to do now is to basically cache it out. Let's just get that color for visualization purpose. We can reconnect that later to the cached sim. So a file cache, and I will call that cache smoke, or just cache vel for velocity. And then you can just, for example, cache to frame, delete the channels, and 6, and then use a file node. And I will call the file node cache underscore vel underscore load. And then we can just hit cache here, cache that whole thing out, so basically the simulation, and then we can load it in here. So go to the file cache node, press right click, copy parameter, go onto your normal file node, right click, paste relative reference, and there we go. We now got our cached velocity simulation. Cool. So now, of course, you can just reconnect that for the visualization. And in the next part, we will then feed that into our volume, in our velum simulation, and then advect the particle, the particles. Of course, you can advect particles with that too, but we will advect then the fabric with our created velocities. One more thing to do for organization. I will just call that initial vel. Cool, so we are done here, and I will see you in the next lesson.